All right, so looking at section 13.2, we're looking at present value with regards to compound interest. So the idea here is you ask yourself, how much would you need to invest or set aside today? How much money would you need today to get to an amount that you would need, that you foresee you're going to have to pay in the future? For instance, and it could be anything business related, it can be any kind of business, any kind of thing you want to purchase. But in this case, you're asking, find the amount that needs to be set aside today to yield a desired future amount. All right, so presently, what do you need, or present value, basically, is the idea behind it. So assume you need $9,000 for a business, or just you need $9,000, and you need it in 2 years. So what would you need to invest to get this $9,000 coming up in 2 years' time? So the interest rate here says that you can find it at 12%, and it's going to be compounded at semi-annually. So you can do this two ways. There is a formula for this, and you can bring up the ebook, or if you have a regular book, it's on page 489. And there is a formula for this, and your future value would go on top, which would be $9,000. And then the rate in our case would be 12 divided by 2, which would be 6, and then the n would be how many periods or compoundings happens. So in this case, you take your rate and you divide it by 2, because it's semi-annually, and you get 6%. That's what you would put here in this formula, that 6% rate. N stands for how many periods or how many compoundings would you have. Well, in 2 years' time, semi-annually, 2 times 2 would be 4. So you would put a 4 right there where that n is, and then you just use your calculator to calculate it. And some calculators actually have a little well, in this case, right here, it tells you an example of how to use your TI-84 Plus. If you have one of these, it's got an app where it asks for all the information. You just hit enter, and it tells you your present value you need. So there is little apps that's available in financial calculators. There's a financial calculator app in that graphing calculator. There's 3 different calculators here that do that. Or you can use a table, and the table is just as fine. It's just as easy. But what you have to do here, like I said, to use this table, they're talking about this table is based on $1. So we want $9,000. So whatever value I get out of this table, I'm going to multiply by 9,000, because this table represents what you would need present value for $1. So it works that way. It works with any kind of, if it's based on $1, it works with any kind of calculation. So here's what you do. You take your rate of 12%, and you, as usual, I say you need to read section 13.2 and make sure you've gone through all their nice definitions and such to explain this. But anyways, you take your rate divided by the periods, or how it's compounded. So if this is compounded quarterly, that number would be a 4. If it was compounded annually, that number there would be a 1. In our case, it's a 2 because it's semi-annually. 6%. So I'm going to look in the 6% column. Okay, I'm going to look in the 6% column. Well, what row do I use? Well, the row is the number of periods. So 2 years, semi-annually, 4 periods. So I'm going to look on 4 periods, 0.79209. That's the value I'm going to multiply by $9,000. When we multiply that out, 9,000 times 0.79209, we get 7,128.81. $7,128.81. So that's how you use this formula, this table. If you use the formula, you would come up with the same answer. The idea here is that if you would need to invest this much money at this rate, compounded semi-annually for 2 years, to get $9,000. We're essentially doing chapter 13.1 in reverse. That's kind of the idea. In reverse, in section 13.1, they said you invest this much money at this rate, at this compounding for this amount of time. What would you get? But now we're saying, well, here's what you need. Here's what you would get. Here's the rates and the terms. What would you need to start with? That's what 13.1 is all about. All right, so let's do it again. Number 2, we want to find the amount that should be set aside today to yield a desired future amount. We want to come up with $7,000, so I want to take $7,000 and times it by some table value. Well, what table value do I use? I'm going to take my interest rate of 8 and divide that by 4 because it's quarterly. I'm going to take 8 divided by 4 and get 2%. All right, I'm going to use the 2% column. Well, what row do I use? Well, 4 years compounded quarterly would be 4 times 4 would be 16 periods, 16 compoundings. So I'm going to use the 2% column and the 16% and the 16% row, 0.72845. So $7,000 times 0.72845. 5,099.15. And that's what we should get. That's how much you need to invest to get to $7,000 in 4 years. Number 3, compute the amount of money needed to be set aside today to ensure a future value of $1,000 in 1 year. The interest rate is 3.5% annually, compounded annually. All right, so the reason why you could go up through here and say if it's 3.5% annually, well, this rate table doesn't use 3.5. So now you're stuck with either using the formula. But here's a trick. If you're only wanting to know 1 year, all right, you want to know it for 1 year, and it's compounded annually. So here's a trick for number 3 and 4. Since it's 1 year and compounded annually, remember that formula that I showed you a second ago? Compounded annually, and for 1 year, that end value there would be 1. So really, all you have to do with these questions, and anything to the power of 1 is itself. So on these questions, all you have to do is say 1 plus the rate, and then for the bottom number, and then the future value would be on the top. So we're going to use this formula. We don't have a table value, so we're going to use this formula. Where'd my marker go? There it is. So we're going to take $1,000, because that's what we want. We're going to divide it by 1 plus our rate. Now 3.5% is 0.035. If I add a 1 to it, just add a 1 out there, 0.035. That's all you do. Because in the formula there's a power. I mean, you can use the power, but in our case, since it's 1 year and compounded annually, 1 times 1 is 1, and anything to the first power is itself. So you just take 1,000 divided by 1.035, $966. 18 cents. And you're thinking, well, why? I can see a lot of value to this idea, because a lot of businesses could see that they're going to have an expense. 1 year from now. 1 year from now, I need to buy a new truck. 1 year from now, I need to buy some new tools. 1 year from now, I'm going to need to buy this for this amount of money. Well, if you can go to a bank and find a CD that's a 12-month CD, or some type of bank that offers this 1 year compounded annually at this rate, well, all I could put, if I had some cash, I could put that down, and that way it would save me $34. And money saved is money earned. So if you're doing this on a grander scale for a larger business, then yeah, you'd want to do this. You'd want to try to set back some money instead of maybe taking out loans. So it's just a little trick of the trade, so to speak. Here you've got the same idea. It's 1 year compounded annually. Here we want to come up with $8,300. Interest rate is 0.05% annually. That's probably what you'll find in well, CDs are a little bit better today, but they're not much better than that. So we want to take $8,300. That's what our future value is. And we want to take 1 plus that rate. Well, 0.85%. Move it twice. 0.0085. So 8,300 over 1.0085. All All right, that's what we want to do. 8,300 divided by 1.0085. 8230.04. All right, save $70. Save $70. All right. Number 4. Same idea here. This guy, he needs to know how much of his money should he set aside to have $24,000 to pay for a van. He's going to purchase it in 1 year. He can invest 1.6% annually, compounded annually. That's our same little trick. That's our same little trick. So let's look at that. We need $24,000. 1 point, and what would 1.6% be? 0.016. So 0.016. That's what we're going to do here. It's a little trick of the trade. 23,622.05. That's how much you're going to need to set aside now to invest to get that $24,000 later. Number 6. Let's see. I need $2,000 in 3 years. What does she need to invest today? She's going to wind up with 2.5% interest annually, compounded annually. So we're looking at the 2.5% column because it's compounded annually, and it's going to be in 3 years. So that's 3 compoundings. 0.92860 times, what does she want? She wants $2,000. 1857.2. So that's how much she needs to invest. Real simple with the tables. All right, how much needs to be invested now? 16% annually, compounded quarterly in 4 years. All right, so 16 divided by 4 would be 4%. So we're in the 4% column. All right, 4 years compounded quarterly is 16 compoundings. So I'm going to go down to the 16, and I get 0.53391 times, and how much do I need? I want to obtain $1,800, $1,800. So I need to invest $961.04, $961.04. Dewey plans to open a business in 8 years. The bank pays 5% annually, compounded semi. So let's take 5% divided by 2 is 2.5. So we're in the 2.5% column. In 8 years, compounded semi would be 16. So 8 times, I'm in the 16 row. So I'm in the 16 row followed over. So there's my table value, 0.67362. We want to come up with $15,000. So he needs to invest $10,104.30, such that in 8 years, compounded, invested in these terms, he can come up with $15,000 to open up his business. Like I said, if you ever have any questions, comments, or concerns, shoot me an email. Just ask.